Hi, boys and girls. It's Miss Bissell. Today we're going to be going over your test on topics 8 and 9, multiplying fractions, whole numbers, and mixed numbers, along with dividing unit fractions and whole numbers. So you need to pull out your notebook where you recorded your answers and work for your test. And we're going to go through the problems and we're going to talk about them. I want you to look at how they should have been set up, how you set them up, and let's figure out if you missed any problems, why you missed them. All right, so number one, we have Sasha bought 12 pounds of blueberries. She put the same amount of blueberries into each of 5 bags with none left over. Which choice correctly describes the amount of blueberries that Sasha put into each bag? Well, before we can tell what whole numbers the answer falls between, we have to actually find the answer. So we are talking about division here. When we talk about putting the same amount of blueberries into each of 5 bags. So we ask ourselves that real quick question, what am I splitting up? And we are splitting up the 12 pounds of blueberries, and we're splitting it between 5 bags. Okay, so to correctly get our dividend and our divisor in the right order so that we correctly answer the problem, this is where we start. We write our fraction or our division problem as a fraction. Since it gives us an improper fraction, we step out to the side and we divide 12 by 5. 5 goes into 12 twice. We have 2/5 left over. So we have 2 2/5. So 2 2/5 pounds of blueberries go into each bag. So what I know from that is that that is going to be more than 2, but less than the next counting number of 3. So my answer choice is C. It is between 2 and 3, which is, B as in boy. Answer B. All right. Again, look at your work. I asked you to set up all the problems so that you had work to look back when we go over. You know, this is math class, and even I, as your teacher, set up every problem and do not try to do mental math, especially on tests. Number 2, a road that is 2 miles long was divided into 3 equal sections. What was the length of each section? So it says we're dividing something, so I know this is a division problem. Again, I never skip asking myself, what am I splitting here? Am I splitting a road that is 2 miles long, or am I just splitting up the 3 equal sections? And obviously, I'm splitting up the road that's 2 miles long, and I'm splitting it between 3 equal sections. So again, we're at the point in 5th grade where we write our division sentences as a fraction. And once we get the fraction, we know whether we need to use standard division and divide, or do we just have a simple answer like 2/3. And we have each section has 2/3 of a mile. Less than 1 whole mile. I would need 3 miles of road for each section to be 1 mile long, so that makes sense. So my answer is going to be C. All right, again, you're looking at your work. You're seeing, is it the problem that you set it up wrong and you have the divisor in the dividend place? Did you skip that important step of asking yourself, what am I splitting into equal parts? Okay, let's look at number 3. Micah brought 30 cupcakes to school. There are 20 students in his class, including Micah. The cupcakes were divided evenly among the students. How many cupcakes did each student get? Again, this is your classic division problem. So what are we splitting into equal groups? We're splitting those 30 cupcakes, and we're splitting them among 20 students, and that includes Micah. So we're doing 30 divided by 20. Like I said, and I've said all along in class, we're writing the answer as a fraction. I can see it's improper fraction, so yes, we do have to do some standard division. So I know that I can make one group of 20 with 30. All right, I have 10 left over out of 20, 10 20ths. I know that 10 is the greatest common factor of the two. So I have 1 1/2 cupcakes per student. So I am looking. I see answer C is the improper fraction 30/20, which equals 1 10/20, which simplifies to 1 1/2. So there's my answer, number 3. All right, number 4. We are looking at which expression represents 5 divided by 8. 5/8 is 5 divided by 8. So again, just reviewing, we know from above that the divisor comes from the denominator. So the denominator is the divisor and the denominator. So we would set it up as 5 divided by 8. C matches this expression. Okay. Again, look at how you set it up. And if you're trying to do math mentally, it's not probably working out very well for you. And I've been trying to emphasize that from the beginning of the year. We do math on paper. As easy as it is, we still set it up. All right, we're going to look at problem number 5. All right, problem number 5 was Miss Ruby has 1 beanbag chair in her room. She lets 4 students take equal turns sitting in the chair during a 38-minute reading period. Which equation shows the length of each student's turn? So I've got students that look like they're taking equal turns. This is a division problem. So I asked myself, what am I splitting into equal parts, the beanbag or the 38-minute reading period? And what I am doing here is and also the 4 students. So I've got a couple things here. So the 1 beanbag doesn't really have anything to do with setting up my problem. What I have is a 38-minute period of time that I'm splitting up between 4 students who are sitting in that beanbag chair. So I'm splitting 38 minutes of time between 4 students. So when I set it up, I get 38 divided by 4, which is 38/4. That is an improper fraction, so I know I need to do some division. I know my math facts, so I know that 4 goes into 38 9 times. 9 times 4 is 36. I have 2 left over, so I have 9 2/4. I look at my fraction. It is going to simplify. The greatest common factor of 2 and 4 is 2. So I have 9 1/2 minutes per student. So I'm going to look back. I don't see the 9 1/2, but I do see the 38/4. So the answer here stopped as an improper fraction. The correct answer is D. All right, let's go to number 6. Cynthia used 5 feet of lace to make 6 ribbons of the same size. Which statement best describes the amount of lace Cynthia used? So Cynthia used 5 feet of lace for 6 different ribbons. This to me sounds like a division problem because I want to know the amount of lace that she used. Excuse me just a second. All right. 5 feet of lace to make 6 ribbons of the same size. So 5 divided by 6. All right. 5 feet of lace is what I'm splitting into 6 different ribbons. So the amount of lace that she used would be 5/6, because the ribbons are all going to be the same size. So I see that answer 5/6 is answer C. All right. Again, you are looking in your math work journal where you wrote out the problems for this test, and you're looking to see how you set them up if you missed them. All right, number 7. A group of 18 students wanted to share 2 bags of chips equally. Which fraction represents the amount of chips each student should receive? So again, we've got a lot of division here. We have 18 students. They want to share 2 bags of chips equally. So we've just got to take a second and ask ourselves what's being split into equal groups, the students or the bags of chips? And they're sharing or splitting equally 2 bags of chips among 18 students. So we get the answer 2/18. If you find the greatest common factor 2 and simplify it, you get 1/9. When you look, 1/9 is not in the answer bank, so you always go back and see if it's in the answer bank in its unsimplified form, which it is. Letter D is the correct answer for number 7. All right, let's look at number 8. And again, these were on the computer screen, so you were recording your work in your book, in your math journal, so that you could have work to look back at today. All right, number 8. In science class, 1/3 of the students have a sister. Of the students who have a sister, 1/2 have a brother. Which model shows the fractions of sisters who have both a sister and a brother? So these are the fraction multiplication models that we were working on prior to our winter break. All right, we saw some of these on our practice quizzes the day before the test. So when we have multiplication of 2 factors, we have one factor that runs horizontally and the other that runs vertically, and where they crisscross is the product. So I have 1/3 of the students have a sister, and of the 1/3, 1/2 have a brother. So 1/2 of 1/3, I can write it either 1/2 times 1/3 or 1/3 times 1/2. It doesn't matter. That is a multiplication of 2 fraction problem. When I work it out, and I gave you a tip that I always work out the actual problems, and then I look for a model that matches not only the factors but also the product, we get the answer, or the product, 1/6. So I'm looking for where 1/3 and 1/2 are crossing, and then I have one area shaded extra dark where they crisscross out of 6 equal parts. So I think this right here is going to help me see it. And the only one that I see that has a very dark 1 square out of 6 is C. So when I check it, I see that 1/2 is shaded this way. 1 of 3 equal parts is shaded vertically. And right here is the product, 1 out of 6 equal parts. So my answer is C. All right, number 9. Barry has 1/3 of a bag of candy left over from his party. Of this candy, 1/3 of it is chocolate. How much of the total bag is chocolate? And again, the word of with a fraction typically indicates that you are multiplying. We learned that. I reviewed it before the test. So he has 1/3 of a bag of candy left, and 1/3 of that bag is chocolate. So 1/3 of 1/3 means 1/3 times 1/3. I multiply the numerators together to get the new numerator of the product, and the denominators together to get to the denominator of the product. And I get that 1/9 of the bag is chocolate. That goes with answer A. All right. Number 10, Brad bought 12 roses for his mother, and 2/4 of them were pink. How many pink roses were there? So 2/4 of them, that means 2/4 of the 12 roses. So there's my multiplication clue. So 2/4 of 12, it's going to look like this. So we learned in topic 8 lessons that we have to have 2 fractions in order to multiply. So we already have our 2/4. We're going to rewrite the whole number as the improper fraction, 12 over 1. There we go. 2 times 12 will give us our numerator. 4 times 1 will give us our denominator. So we get 24/4, an improper fraction that we're going to divide to see what mixed or whole number that is. 4 goes into 24 6 times even. So we have 6 of the roses are pink. Now, that's answer A. Some of you might have used the cancellation method in this multiplication problem, and you might have noticed that 4 and 12 have the greatest common factor of 4. 4 divides into itself 1 time. It divides into 12 3 times. And you folks would have been multiplying 2 times 3 equals 6. 1 times 1 equals 1, and 6 over 1, the improper fraction is 6. So if you use cancellation, just wanted to show you what your work would have looked like. All right, let's look at number 11. We're halfway through. Again, you're doing some error analysis. You're looking at what you missed and why. As you noticed, Ms. Bissell has written something for every problem, which means that as fifth grade students, you folks should have every problem written out. I know I'm writing on the paper where the test is, just so I'm not having to go back and forth from the computer screen to paper. But what I'm writing on this paper, you should have written in your math journal. That's how we show work. That's how we analyze what we're doing wrong. And one of the best ways we learn is from our mistakes. Number 11, Jason bought a rug, and it covers 2/3 of the floor's length and 3/4 of the floor's width. How much of the floor is covered by the rug? All right, so let's look at this again. The rug covers 2/3 of the floor's length and 3/4 of the floor's width. How much of the floor is covered by the rug? We're really looking at how much area does it take up. So we multiply the length and the width. Doesn't matter which factor you want to put first. All right, when we multiply, we get 2 times 3 for the numerator and 3 times 4 for the denominators. That gives us 6/12. 6/12 has the greatest common factor of 6 and 12. So we have 1/2. So it covers 1/2, and that goes with answer choice A. All right, number 12, we have another multiplication model. This time we want to find out which model best represents the expression 1/4 times 1/3. So again, my tip was to always go ahead and find the product. And so we're going to have 1/12 should be what is, in this case, where the crisscross is. It looks like they have a diagonal line. So we're looking for where 1 out of 4 rows or 1 out of 4 columns is shaded. Then we're looking for 1 out of either the rows or columns out of 3 are shaded, and 1 out of 12 equal parts will have the diagonal where they've got the crisscross going on. So I am looking, and to me, it's answer A. I see 1 out of 4 columns. I see 1 out of 3 rows. Where the crisscross is, where they crisscross, the product is 1 out of what is now 12 equal parts. None of these others match that. All right, A, 1/12. Number 13, a rectangle is 3/4 of a foot long and 5/12 of a foot wide. What fraction represents the area of the rectangle? Whoops, sorry. Pull that back down. All right, so it's 3/4 of a foot long, 5/12 of a foot wide. What fraction represents the area of the rectangle? So guys, 3/4 times 5/12 is how we set up, because area equals length times width. Numerators multiplied together, denominators multiplied together. Let's see what we get. 3 times 5 is 15. 4 times 12 is 48. All right. I'm looking. I could see if it's simplified, but real quick, I glanced over at the answer bank, and I see that the answer is there. It is answer A. So when we're looking for area, you guys are multiplying the length times the width to get the area. So that's what we did here. 3/4 times 5/12 gave us the area of 15/48 of a square foot. All right, let's go to number 14. Which fraction goes in the box to make the sentence shown below true? So 3 times blank equals 3. Well, we know the identity property of 1 means that 1 times any number equals itself. But we don't have 1 in our answer bank. But what I do see is that 2 halves has the same value as 1 whole. Right? If you have 2 halves of a pizza, you have a whole pizza. All right, 6/3 would be 2 wholes. 3/2 would really be 1.5, and then 1/3 would be less than 1. So the answer is going to be 2/2 because 2/2 has a value of 1. So 3 times 2/2 would equal 3. All right, number 15, Mary wrote the comparison shown below. 5/4 times 6 is greater than 6. So is this comparison true? So is the product of 5/4 times 6 going to be greater than 6? Well, let's talk about this. If we multiplied 1 times 6, we know it would equal 6, correct? So whatever I multiply times 6, in order for it to be greater than 6, this factor has to have a value greater than 1. Well, 5/4 is greater than 1. As a matter of fact, 5/4 is really 1 and 1/4, and that is greater than 1 whole. So if this factor is greater than 1 whole, when I multiply, my product is going to be greater than 6. So the answer is yes, because 5/4 is greater than 1 whole. All right, number 16. We're getting there, folks, almost. Number 16. So here's some more models. So last night, Davis did homework for 5/6 of an hour. He spent 1/3 of that time working on math. Which model shows the fraction of an hour he worked on math? So again, this is a multiplication model. All right. He did homework for 5/6 of an hour. 1/3 of that time was working on math. So 1/3 of 5/6 of an hour. And we know of with fractions generally means we're multiplying them. So like I said, before I even look at my model answers, I like to go ahead and get the product. So I get 5/18 of an hour. All right, let's see if that helps me at all. All right, so I'm looking for a model where one row or one column is shaded. Oops, we're using diagonal. So looks like where one's going one way and the other's going the other way. So I'm looking at A. I see that the backward slash they used on this bottom row, and that's 1 out of 3 rows. So now I'm looking to see, did they use the forward slash on 5 out of 6 columns? 1, 2, 3, 4, 5. Yes, they did. Where they crisscross are these 5 squares out of this new array of 18. So it looks like it's going to be this model. This right here is not a multiplication model. Doesn't look like a row and a column. Neither this one, they never cross. This one, you've got diagonals this way and diagonals this way, but they're both columns. One needs to be a row, and where they crisscross is where that product's going to be. So the only answer could be A. All right, so I see my 1/3 in the rows, I see the 5/6 in the columns, and I see the product where the X's crisscross, where there's 5 out of now 18 equal parts. So the answer is A. Number 17, a scientist completed 1/3 page of a report each hour. The report was 5 pages long. How long did it take the scientist to complete the report? Hint, 5 divided by 1/3 equals the number of hours to complete the work. So the hint tells you how to set up the problem. So 5 pages divided by 1/3 of a page each hour. To set it up, I'm going to take 5 hours. So I'm going to use a circle to represent the 5 hours. Each one is going to be broken into thirds. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 thirds in 5 wholes. So 5 divided by 1/3 equals 15 hours. Answer is D. All right. The last couple questions, number 18. Which expression does the model below represent? I have 3 holes that are broken into 1/3 parts. So for me, I am seeing that this is a division problem where I see 3 models, 3 holes are divided into 1/3 parts, and there are 9 of them. So that looks like 3 divided by 1/3 has to be answer choice C. All right, number 19. Mrs. Johnson brought 1/3 of a pizza home from her dinner out with her friends. She gave each of her 4 children the same amount of leftover pizza. What part of the whole pizza did Mrs. Johnson give to her children? So she brought home 1/3 of a pizza. And it says right here, she's going to give each of her 4 children the same amount of this leftover pizza. So we're going to be splitting the third of a pizza into 4 equal groups. Each child gets part. All right. So if we have 1/3 of something and we split it into 4 equal parts, we have to split each of the other thirds into 4 equal parts. And then we count how many equal parts there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So every child gets 1/12. Each of these parts is 1/12. Okay. The only thing that can happen when I split a fraction into equal parts is I get a smaller fraction. So my answer is D. All right, the last question. Keith has 10 yards of fishing line. He wants to cut the fishing line into pieces that are 1/4 yard. How many pieces of fishing line will Keith have? All right, so if you're cutting it, you're splitting it into equal parts. He wants them to be 1/4 of a yard long. So I ask myself, what am I splitting into equal parts? I'm splitting 10 yards of fishing line. I'm splitting it into 1/4 yard long sections. I want to know how many pieces there are. So if I take 10, I'm going to represent each hole with a circle like we've represented them in class. All right, I'm going to break each one into 4 equal parts. So I know these aren't perfect, but when we take a test, we work efficiently. All right, so I have 4 parts in each of these models. So I have 40 1/4 yard long pieces of fishing line. All right, 10 divided by 1/4, there are 40 1/4 parts. I'm looking, it's answer choice D. All right, so boys and girls, we have gone over our test. All right, hopefully you have spent time looking at what you did right and what you did wrong. You should have had a problem shown or had work shown for every single problem. Miss Bissell just took the whole test. I did nothing with mental math. Everything I worked out. All right. So those of you that stayed with me till the end, I'm going to go ahead and tell you you're working on weekly review handout 20 today. All right, you're working the first 3 problems. So number 1, Lizzie needs to simplify this expression. 100 minus 8 times 7 plus 20. She uses the order of operations to decide which operation to evaluate first. Then she inserts parentheses around the operation. Which operation does she write? So boys and girls, you have to know the rules for the order of operations. We make a little graphic organizer, hint, hint, called Pemdas, and that will help you decide which of the operations you do first, the subtraction, multiplication, or the addition. All right, for number 2, Nicholas multiplies the fraction 5/6 by a whole number greater than 1. What can you predict about the product? All right, so this is where we can predict the value of a product based on the 2 factors. So I'll give you a hint. Any number multiplied by 1 equals itself. Any factor multiplied by another factor less than 1, it's going to be less than the second factor. And any factor multiplied by another factor that has a value greater than 1, the product's going to be greater than that factor. All right, so let you work on that. Number 3, need to work this one out on graph paper. How many 1/4 yard pieces of pipe can be cut from a 5-yard long piece of pipe? So you're asking yourselves, if you're cutting something up, I would say you are dividing it into equal parts. So what are you splitting into equal parts? 1/4 yard long pieces or a 5-yard long piece of pipe? Yes, you're going to divide the 5-yard long piece of pipe into 1/4 sections. So 5 divided by 1/4, and then you are going to find that number of pieces of 1/4 yard pipe and box that in and write it on the line here. All right, the last thing that you're going to do for me, we've gone over your test. We've previewed the first 3 problems of your weekly review. The only other thing I need you to do is to whip out a sheet of paper that you're going to use to work on your iReady lessons. Those of you that have not finished the iReady diagnostic placement, you need to finish that. So if it takes you 15 minutes, you need to get that done. If it takes you a little longer, you need to work until that's done. Most of you are done with it. So you are in the lessons that you need to be in based on your level of mastery with the 5th grade, 4th grade, 6th grade concepts, whatever you're at. You need to do your best on your lessons, but just set a timer for 15 minutes and you can check your dashboard. This week, my goal is going to be 45 total minutes. Don't forget, we're not just going for time. We're going for, do we understand the lessons? Are we giving our best? All right, if you need me, you can jump on to the Google Meet. The actual code to get on is Pacell Math. If I'm not on and you need help, send me an email. I'll email you back and confirm that it's good for us to get on. All right, have a great day, and I will talk to you soon. Reach out if you need me.